Hello everyone. So today we are going to see about the manufacturing process of piston. Myself Komal Kiran Fasale. I'm pursuing education of Extra BTech Mechatronics at Rajaram Batu Institute of Technology, Rajaram Nagar, Sakra. So the course name is Manufacturing Process and Machine Tools under guidance of Professor M.V. Pisar sir. So let's have a quick review on the contents. Introduction, manufacturing processes. These are the following processes, and last one is references. So let's see about the piston. So the piston is a very important component used in engine, pump, cylinder, compressor, etc. It is a moving plug-in cylinder which form bottom part of a combustion chamber. Its purpose in engine is to transfer force from expanding gas to the crankshaft while connecting rod, providing 60% of friction in engine. We see that the piston plays important role in many assembly lines, and it is a solid cylinder disc consists of various parts like crown, ring, lance, grooves, grid, and waste pin bars. And now we are going to see the detailed information about the processes involved in manufacturing of piston, which is as follows. The first one is a material selection, which also includes the manufacturing process. So piston contributes to overall performance of engine. Thus, the material for the piston are selecting considered requirements like height range, small specific gravity, coefficient of friction, abrasion, corrosion, resistance are factors, easy to process, and low coefficient of thermal expansion. Mostly the cast iron, steel, and aluminum alloys are the materials used, but the cast aluminum is widely used out of all these materials. Pistons are manufactured by casting or forging processes, where casting is the most effective and affordable process. Different casting processes as like die casting, centrifugal casting are also used, but the gravity die casting is the most commonly used process as in a short amount of time many components we can manufacture. So the next step is the pattern making and the mold. Pattern includes pattern, core, and gate system, which are selected based on the requirement. So the selection of mold machine from the two separate metal blocks which are created precisely to that they fit together and can be opened or closed easily. Gating system and the part geometry are also machined into a casting mold. As the process considered is permanent die casting type, suitable measures are taken so that mold can be used again and again. Mold will be heated before pouring of all the metal casting. Vertical sand core is used as a hollow part which is kneaded and thus all is assembled together. So this is the diagram. So we can understand about the pattern making and mold. This is the half mold. This one is also half mold. These are the two half molds of a process. And for getting the required cavity, we use the sand core here, and using the screw after assembling these two half molds, we can pour the molten metal using the screw into the cavity, and we will get the desired product. So let's see about the selection of furnace. As the molten metal will be a cast aluminum or alloy, crucible furnace is the mostly used and a suitable one as it melts the metal without direct contact with a burning fuel mixture and a gas for specialty alloy lines. So ingots of aluminum are heated in the furnace. After heating, molten metal is poured in mold by ladle from the crucible. So here is the ladle used for pouring the molten metal in the cavity. So next step is solidification and cooling. After a particular amount of time, once the metal cools and solidifies, the segments are detached. The last part is obtained by separating from mold cavity. Further process are done to get the final product. So the next one is the heat treatment and inspection of the physical properties. Piston castings are subjected to solution treatment and precipitation. So the forced air circulation furnace with a sophisticated programmable temperature controllers are used for heat treatment. All heat-treated components are inspected for hardness requirements, tensile and elongation properties. So the next step is Machine soft and inspection. The machine process and other processes are used to obtain the final product. This includes the dehorning, hardening, turning, CNC lathe machining, oil slots and pin boring, grinding, etc. So we'll see one by one. The dehorning, it is done by the vertical milling machine. The next one is hardening, done in oven before machining, as shown in the diagrams. Then turning to get the smooth profile to cut rough edges. Then CNC lathe machining to cut ring, grooves, make accurate bore diameter finish crown where a script is finished prior to this. Then the 5-axis VMC machine and the oil slots and the pin bore are obtained. The grinding to get the fine finish tolerance and surface finishes. And the processes deliver high accuracy and consistency. Components are inspected to measure all these parameters. Then cleaning, inspection and packing. Pistons are thoroughly cleaned and degreased by using suitable means. Fully automatic machines using water-soluble solvents are also used. Thereafter, components are over-dried and checked for proper cleaning. After cleaning, components are inspected and graded according to the requirements. Thus, after all these processes, the final product is properly inspected prior to packing and are then dispatched. So the outcome of this topic is the brief study of all the processes in manufacturing which teaches to select the proper materials and means to develop a product. The evaluation of processes helps to understand the fundamental parameters of manufacturing, and to produce a component it requires a precise proper process to obtain the accurate product. So these are the references I have referred. There are many others. So thank you everyone. Thank you.